Hello everyone. Today's topic of presentation is minimization of DFA. Myself, Juli Yadav, Assistant Professor in Ajay Kumar Garg Engineering College, Ghaziabad. So what does this minimization of DFA is? Basically, minimization of DFA is the process of reducing the number of states of DFA to its minimum states is known as minimization of DFA. Basically, as we know, while we are converting NFA to DFA, the number of states increases, due to which the complexity also increases. So, to reduce the complexity or the number of states in DFA, we need to do the minimization of DFA. So, in minimization of DFA, the DFA should contains the minimum number of states. It should contain the minimum number of states. So, to minimize the DFA, we have two theorems that can be used for the minimization for the minimization of DFA or reducing the number of states in the DFA. So, two theorems are, first one is equivalence theorem, and another one is Mayhill necroed theorem. So, both the theorems are used for the minimization of DFA. So, let us understand what this equivalence theorem is. Basically, the equivalence theorem is when we are comparing the states. Let's understand it in more clear ways by using an example. So, by using equivalence theorem, so the example is, let us take a DFA So this is the DFA to which we are going to minimize it. How can we minimize it? By using an equivalence theorem. So the first step is we have to divide this into two we have to divide this into two sets. The first set contains all the non-final states and the second two contains the states that are final. So let's, this step 1 is, firstly we have to remove all the unreachable states. Right. Then second step is we have to divide this into two groups, or we can say into two sets. The first so let us contain phi 0. This represents the first state or the first partition. That will be all the non-final states, like here it is Q0, Q1, Q3 and Q6. So all the non-final states comes under one set. Let's suppose this is G1 and another set contains all the final states. Final states are Q2, Q4 and Q5. Now we have divided it into two sets. The next step is we have to check that for which transition the next state occurs in which of the set. Let us consider the first set is Q0 and Q1. Now we have to check the transition Q0 and Q1. Let's make it more clear by making a transition table. Q0, Q1, Q2, Q3, Q4, Q5 and Q6, and it has two inputs, that is A and B. A and B. So here are the inputs and here are the number of states. So for from state Q0 on input A, it goes to state Q1. For input B, it goes to state Q3. From state Q1, for input A, it goes to Q2. And for state Q1 on input B, it goes to Q4. And from state Q2, for A, it goes to itself, and for B, it goes to Q1, and Q3, A goes to Q2 and B goes to Q5. Q4, A goes to Q4 and B goes to Q5. For state Q5, for A, it goes to self loop, and for B, it goes to Q4. Now, for Q6, A goes to Q3 and B goes to Q6. So, by using this transition table, this is the transition table. And this one is the transition diagram. Right. Now we have to check. First step is to check Q0 and Q1 transition. Let's check on state on input symbol A, Q0 goes to Q1, and on input symbol A, Q1 goes to Q2. Now we have to check whether Q1 comma Q2 lies in the same set? Let's check. Q1 is in G1 set and Q2 is in G2 set. So we cannot combine these two states. And if we get the solution from the first, for the first input symbol, like here, from state Q0 to Q1, for input A, it goes to Q1, and for from Q1 to Q2, it goes to Q2 for input A. So we have to check whether Q1 and Q2 lies in the same set, but here we can see the Q1 and Q2 lies in the different set. So what we have to do, we cannot make them as one state. If they, if the output from Q0 comma A and Q1 comma A comes in the same set, then we have to check for another input. That is for B also we have to check. But in the first case, they both are from the different set, so we cannot combine these two states. Now we have to check for Q0, Q3. Q0, Q3. For state Q0, on input A, it goes to Q1, and for state Q3, on A, it goes to Q2. Again, Q1 and Q2 both are in the different set. You can see here, Q1 is in G1 and Q2 is in G2. So we cannot combine these two states. Next is, we have to check Q0 and Q6. Now let's check here. Q0 and Q6. Q0 on input A goes to Q1. It goes to Q1, and Q6 on input A goes to Q3. As now we have to check whether the Q1 and Q3 lies in the same set. Q1 and Q3 both lies in the same set. Then we have to check for another input symbol, that is B. So on Q0, on B it goes to Q3, and for input from state Q6 to input B, it goes to Q3 and Q6. Now we have to check whether they both lies in the same set. Q3 and Q6, they both lies in the same set. So we can make a set of Q0 comma Q6. Now we have to check for Q1 comma Q3, Q1 comma Q3, Q2 and Q for input A, it goes to Q2 comma Q2, but for input B, it goes to Q4 comma Q5. Let's check here whether they both are in the same state. Yes, to Q2 and Q4 lies in the same set or same group. So we can combine the state Q1 comma Q3. Right. Now we have to check whether Q1 and Q6 lies in the same set. Now we have to check it here. Q1 is Q2 and Q6 is Q3. Q2 and Q1 and Q2 and Q3. Now let's check whether these two lies in the same set. Q2 is in G2 and Q1 is in G1. So we cannot make them in a single set. So the phi 1 means partition 1 we have done at phi 0. Now phi 1 is Q0 comma Q6. We combine these two states and then we combine Q1 comma Q6. Now we also have to check whether Q3 and Q6 lies in the same set. Q3 and Q6. Q3 is Q2 and Q6 is Q3. We cannot make them as a one state because they both are in the different sets. So the set would become Q6. So after partition G1, we get phi 1 as Q0, Q6, Q1, Q3 and Q6 as the individual states. Now we have to check for another set, that is Q2, Q4, Q5. First we have to check Q2 and Q4. Q2 and Q4. Q2 on A goes to Q2, it goes to Q2, and Q4 on A goes to Q4. Let's check whether they both lies in the same set. Yes, they both lies in the same set. Now we have to check for another input B. For B input, it goes to Q2 or it goes to Q1 and Q4 it goes to Q5. Q1 comma Q5. Let's check whether they both lies in the same set. No, they both lies in different set. So we cannot combine these two states as a single state. So now we have to check for Q2, Q5. Q2, Q5. Q2 is Q2, Q5 is Q5 and they both lies in the same set Q2 and Q5. Now we have to check for another input. Q2 is Q1 and Q4. Q1 and Q4 they both lies in the different sets. So we cannot combine Q2 with Q4 and with Q5. So Q2 remains individual. Now we have to check for Q4 and Q5. Q4 on A input goes to Q4 and on B input it goes to Q5, and Q5 of A input goes to Q5 and B it goes to Q4. So Q4 and Q5 both lies in the same set. So we can say we can combine them as one state, Q4 and Q5. So from from partition phi 0 we get the following sets. Now we have to again do the checking of whether the transition state lies in the same set. So now we have to find. So in the previous we got phi 0 as Q0, Q1, Q2, right, and again the set we got is Q3, Q4 and Q5. These were the sets, and after doing the partition in first phase we reached to phi 1, that would be Q0, then it would be Q1 comma Q2 and the last one is Q3 and Q4 comma Q5. So after partition first we reach to the following states. Now we have to again doing the partition, that means we have to do phi 2. So the transition table, let's make transition table Q0, Q1, Q2, Q3, Q4 and Q5 and Q6. Q1, Q3, 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 Q4, Q3, Q4, Q4 and Q6. Now we have to check whether these two lies in the same set or not, as this one is already clear that it cannot club with any other state. So we have to check it for Q1 and Q2. Q1 and Q2 that is at input A it goes to Q3 and Q3 same, which lies in the same set. Then we have to check for input B Q4, 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 Q4 means they are remains the same. There can be no further partition. Then Q3 is already final and Q4, Q5. We have to check for these two states also, Q4 and Q5. They goes to Q4, Q5 and Q5, Q4. Now we have to check in previous partition, Q4, Q5 lies in the same set. So how we can terminate by for doing or of doing the partition? How we can terminate? When we got two partitions as same, we can see here phi 1 and phi 2. both the partition contains the same number of states with the same set of symbols like Q0, Q0, Q1, Q2, Q1, Q2, Q3, Q3, Q4 and Q5. We cannot partition it further. When these two partitions are same, means phi 1 is equals to phi 2. This is the terminating condition, else it is the condition like phi of I minus 1 equals to phi of I. Here I is what? The second partition, and here I is phi I minus means 2 minus 1, it is phi 2. So, it is phi 1 equals to phi 2. This is the terminating condition at which we have to terminate the further partitioning. So, here we get Q0, Q1, Q2, Q3, Q4, Q5 as in place of 6. In earlier states, we have 7 states. Now, how many states do we have? We have only 4 states. Now, let's make a DFA, or we can say the minimized DFA of these following states. So, the minimized DFA, what were the states that we have? Q0, that is our initial state. Now, another state is what? Q1, Q2. So, another state is Q1, comma, Q2. Then, another state is Q3. Let's make it here. Q3, and the last state is Q4 and Q5. Let's check whether we have marked all the states Q0, Q1, Q2, Q3, Q4 and Q5. We have marked all the states. Now, as in the previous DFA, Q0 is the initial state, and in the previous DFA, states Q3, comma, Q4, comma, Q5. These were the final states. These were the final states. So, we have to, how we can mark the final states? We have to check whether these states lies in which state, like Q3. Q3 is an individual state, as it was the final state in the previous, or we can say the DFA that was not minimized, or DFA before minimization, this was the final state. So, we have to mark Q3 as the final state, and another one is Q4, Q5, which are clubbed as a one state. In place of doing all these, we can also use another notation, like in place of Q0 we can take A, in place of Q1, Q2 we can take as B state, in place of Q3 we can take it as C state, in place of Q4, comma Q5 we can take it as another state, that is D. That is your preference, whether you want to use the same sets, or you want to represent the states by using the same symbol that were in the previous DFA, or you can name them using another names like I have shown here. You can also use these. Right now, we have to show the transition. So, from state Q0, that was the initial state, from state Q0 on input A, it goes to Q1. So, from state Q0 on input A, it goes to Q1. Now, Q1 is in which state? In this state. Right? Q1 is in this state. Now, Q0 on B input, it goes to Q2. Here we can write the transition del of Q0 comma A goes to Q1, del of Q0 comma B goes to Q2. So, these two states Q1 and Q2, they lies in the same state. So, we can mark here A, comma B. right? Why we have marked here A comma B? Because the next state reaching from Q0 on input A and B remains in the same state, that is Q1 and Q2. That's why we have marked here QA comma B. Now, next state is what? Q1, Q2. Now we have to check the transition for both the states. Let's see here. If next state is our Q1 and Q2, then we have to check the transition for both these states. On input A, Q1 goes to Q3. On input A, Q1 goes to Q3, and on input A, Q2 goes to, on input A, Q2 goes to Q3, right? For input A, both the states, either Q1 or Q2, they goes to the same state. Now we have to check for another input symbol, that is B. So we can mark here, like if both the states goes on input A to Q3. So from here to here on input A, Q1 and Q2 both takes input A and goes to state Q3. Now we have to check for another input, that is B. So Q1 on B goes to Q4, del of Q1 comma B goes to Q4, right? Now Q2 on B goes to Q5, del of Q2 comma B goes to Q5. Now we have to check whether we have marked for input A from state Q1 to Q2, that has to be reached, or the next state from both the states is Q3, so that we have marked here. Now for input B from state Q1 it goes to Q4, and from a state Q2 on input B it goes to Q5. Now we have to check whether these two states are combined as one or we have to mark them individually. Now we can see here that Q1, Q4 and Q5 both are clubbed as a single state. So as we know that Q4 and Q5 is the final state as Q3 is, so we have to mark the final states with the double circle. So on input B, from input B, so for input B, Q1, for input A it goes to Q3, and for input B it goes to Q4 comma Q5. Now we have done the transition for both the states Q1 and Q2. Now next state is Q3. We have to check the transition for Q3. Q3 on A goes to Q3 and Q3 on B goes to Q1. Now let's check Q3, del of Q3 comma A, it goes to Q3, and del of Q3 comma B goes to Q1. So for this, for input A, there is a loop. So here is a loop for input A because it goes to the same, or it remains in the same state. Next is for input B, it goes to state Q1. Now we have to check where the Q1 state is. Q1 state is in Q1 comma Q2. So we have to mark it as B. So we have done the transition for both the inputs of state Q3. Now moving towards the next state, that is Q4 and Q5. Q4 and Q5. Why we are not considering this state? I will tell you later. Let's see the transition for state Q4 and Q5. So, for state Q4 on A, it goes to Q4. Now, let's mark it as del of Q4 on A, it goes to Q4. Now, let's check it for Q5 on A goes to Q5. So, del of Q5 comma A, it goes to Q5. Now, we have to check Q4 and Q5, they can be lie in the same state. Let's check here. So, from A, it goes to so from state Q4 and Q5, for input A, Q4 goes to Q4, and for input A, Q5 goes to Q4. So, there is a self loop for A. Now, we have to check for another input symbol. Q4 on B goes to Q5 and Q5 on B goes to Q4. So, del of Q4 comma A, it goes to Q5, and del of Q5 comma A, it goes to Q4. So, for input A as well as for input B, they remains in the same set. Now, we have to see why we are not considering this state. We are not considering this state. Let me explain it to you with the help of the transition diagram. So, we can see here that when we were doing the partitioning, we have removed the state Q6. Why we have removed? Because you can see here, from state Q0, you can reach to state Q1. You can reach to state Q2 by using state Q1, and this is the final state, right? From state Q0, from state Q0, we can reach to the any of the final state. How? From Q0, Q1, Q4, and from state Q0, Q3 and Q5. Means from state Q0, we can reach to all the final states. From state Q1, we can reach all the final states. From state Q3, we can reach all the final states. Now, if we are focusing on Q6, here we can see Q6 is not reachable by any of the state. Is it reachable by any of the state? No, because there is no state which shows the transition. Means there is no state which shows the transition of Q6. There is no transition for Q6. Q6 can reach to state Q3 using using input symbol A, but Q6 cannot be reached by any of the other states. So, we can say that this state is the unreachable state. So, that's why we have removed this state from the transition diagram, and that was our first step was we have to remove all the unreachable states, right? Now you can see here we have used the transition of this DFA using their own states. We can represent it by using another notations, like if we are making a minimized DFA using these notations AB, we have marked A as the initial state, and then B as Q1, Q2, C as Q3, and D as Q4 and Q5. So the same transition we have to show A comma B, A, B for A, and there is a self loop for A comma B, and then this is the, so using another notations, the same output we got for both the notations. And this is all more from my side. There is a question for you all. You have to minimize this given DFA using equivalence theorem. Q0, Q4, sorry, this one is Q3, here is Q0, Q4, Q1, Q2, and this one is Q5. This is the initial state. This one is final, this one is final, this one is final. Now the transitions are, if this is the initial state Q0, 0, 0, on 1 it goes to Q1, it goes to Q5 for 1, and for 0 it goes to Q2, and for Q2 on input 0 it goes to here, and for 1 it goes to Q5, and from state Q4 it goes to Q5 on input 1, and it goes to Q2 on input 0, and it goes to 1 on for input 1. So this is another example that you have to solve. So first step is we have to remove the unreachable states. Is there any unreachable states? Let's check it. We can reach here, we can reach here, but we can reach here also, here also. So there is no unreachable state. That was the first step. Remove the unreachable state. But there is no unreachable state, so we cannot perform step 1. Step 2 is divide the states into it. Group the states as final and non-final set. States of set. So phi 0 is what? Non-final states are Q0, it is final, then Q3 and Q5. So these are the non-final states, and final states are Q1, Q2 and Q4. So this is the partition 1. Partition 2 has to be done, that is phi 1. So for make it more simpler, let's make the transition table. Q0, Q1, Q2, Q3, Q4, and Q5. 0, 1. For 0, it goes to Q3. For 1, it goes to Q1. For 0, it goes to Q2. For 1, it goes to Q5. From state, for 0, it goes to Q2, and for state Q5. Q3 goes to Q0, and it goes to Q4. Q4 on 0 goes to Q2, and on 1 goes to Q5. Q5 on 1 goes to Q5 on 1 goes to Q5, and on 6 goes to Q5. So you have to solve it further. This is the homework for you all. I have done the first step. Another steps you guys have to do. Thank you so much.